Welcome to MrCScience.com's video on the law of mass conservation. We're going to talk about the conservation of mass. We're going to use experiment 2.1 to demonstrate this and kind of drive it home. First question you have is, what is the law of mass conservation? Okay, as it states in the book, matter cannot be created or destroyed. It can only change forms. Now, matter is defined as anything having mass. So, matter for this is it can't be created or destroyed. So, the matter we're talking about in chemistry is the atoms that make up the different molecules and elements that we work with. So, they'll be rearranged, but never will we do a chemical reaction where atoms are destroyed or atoms are created. Okay, so let's move forward here. We're going to do experiment 2.1 from your book on page 47. When we do experiments in class, we write them up like college students or even professionals would write up their experiments. The reason we write up experiments is that if you do discover something interesting and you want someone to try to reproduce your results, then they have a how-do sheet right in front of them to do it exactly like you did it and hopefully get the same answer. So the reaction we're going to do for the law of mass conservation here is we're going to take vinegar and combine it with lye. Now we're going to use something called, or something that's become rather famous with Apologia, is red cabbage juice. Red cabbage juice is a good, here, let's see if I can get a good shot. There we go. Red cabbage juice is a good pH indicator. The pigments within the red cabbage, called anthocyanins, they change color in the presence of an acid or a base. In the presence of an acid, it will change pink. In the presence of a base, it will change green or yellow, or if you get extremely strong, it can go clear. Okay, so let's go ahead and first begin writing up our lab. So in the class, you'll need either a lab notebook or you'll need individual sheets for the labs. On the website, if you're taking this strictly online, the website should have information for you on how to turn in your labs so that I can get them. So in your lab notebook, go to a brand new sheet, and at the top of that sheet, put in Roman numeral 1 and title, colon. You should follow this. This is how everyone writes them up. So, okay, the title of our lab is the law of mass conservation. Okay. Underneath that, next line, Roman numeral number 2 is our purpose. I can't type. There we go. Every lab should have a purpose. Okay. Our purpose is to test the law of mass conservation. Okay. Underneath that, Roman numeral number 3 is hypothesis. If I'm moving along too fast for you, feel free to pause the video and catch up and then start it up again. Okay, every lab should have a hypothesis, what we think is going to happen. So, in a vinegar and lye reaction, I'm going to move my mouse, mass will be conserved. So what we're going to do is we're going to react the lye and the vinegar together along with the pH indicator, which will show us that a chemical reaction has occurred. One of the indications of a chemical reaction occurring is change in color. We're going to weigh the mass of the whole apparatus and all the chemicals before and then after, and we're going to see that hopefully they're the exact same. Okay. So now let's move on to Roman numeral number 4, materials. Oops. Materials is a in-depth list of exactly what you use in your lab, so that if someone wants to create it, they can recreate it exactly like you've done it. In this book, we're not going, or in this course, we're not going to worry about writing out our materials so that anyone can carry it out. We don't. It's kind of a waste of time for us. So what we're going to usually have as per, text. Okay. Procedure. Roman numeral number 5. Procedure is similar to materials. It's a very extensive and in-depth list of exactly how you carried out the lab so that it can be carried out in the exact same way, thus reducing the chance of introducing other experimental variables that could cause the lab to work differently. Again, procedure, we're not going to spend all our time writing it out. It's in our textbook, so we're going to do as per text. And that's followed by Roman numeral number 6, observations. Here we're going to record all the data and observations we get. We're not going to analyze that data, just record. So let's move over to our experiment. Okay, so what we need is, I boiled some red cabbage in distilled water. Distilled water is pH neutral, pH is 7. So neither acid or base, although that's a lie because you'll learn later in the class that water can be an acid or a base. So then I have an apparatus we're going to use. This is also washed and rinsed in distilled water. So what we're going to do is, first of all, we're going to put some vinegar into our beaker. I don't really care a lot about the amount because we care about the change in mass, not the actual amount of mass. So I put about 100 milliliters, about 50 milliliters in there. So that's good. So now we're going to add a little of our red cabbage juice, and you'll see a color change. Cabbage changed to, the vinegar changed to pink, indicating an acid. So that's going to be our first observation. So we'll go back to your lab notebook, and under observations we're going to add vinegar changed, or vinegar turned pink when cabbage water added. Okay. We're not going to say that thus indicating an acid because that would be analyzing your data instead of just recording observations. Okay, now we're going to set up the other part of the experiment. So we don't need the cabbage juice right now. We're going to set it up so we're going to be able to add vinegar to our, or lye to our vinegar. So we'll use this to stir, so I'm going to weigh that as well. And then I'm going to use lye. Lye has some safety concerns. It is a very caustic base. It can burn you. Generally, this lye is solid. Generally only burn you if it's liquid, but it can sit on your skin for a while and absorb some of the moisture from your skin and turn liquid and start burning. The lab says to use gloves, but I'm like 4 feet from my kitchen sink, so I can always rinse off if I need to. So what I'm going to do is I'm going to take some of this lye. Well, one thing you should definitely use while you're using lye is eye protection. If you get lye in your eyes, it will, first of all, be very painful and can cause damage, possibly permanent damage. So wear eye protection while doing this. So we're going to place our lye on top of there. So we got our lye, our vinegar, our pH indicator all there, all ready to go. We're going to put it on our 3-beam scale here. If you haven't used a 3-beam scale before, the center's 100s, the back's 10s, and the front's 1s. So you start with the 100s, you move it up, not too heavy. Well, what we're trying to do is we're trying to get this line and this line to match up. That means that it's in balance and we got the right reading. So 200 is not enough, 300 is too much. So we're going to back to 200, we're going to go up by 10s. 10, 20, 30, 30 is too much. We're going to back off to 20. Now we're going to do our slider and try to get it to balance out. Okay, so went a little too far, it looks like. Yep, so we're going to slide back. Give it a second. We're pretty close. Let's see where it ends up. So watching this, looks like we're a little high, so that means we don't have enough weight on this side. So we're gonna Move it over just a hair. And looks like we're pretty close. Almost stopped. Okay. Maybe just a hair low, but we're just going to remember we're hair low. We're going to go off of here. So we got 224.2 grams. So we're going to record that as our beginning mass. So go back to your lab book. Oops. And I'm going to write beginning mass 224.2 grams. In chemistry, make sure we have those units so you know what you're working with. So, okay, so now we're going to do our reaction. Let's flip back to our screen here. Okay, so we got our apparatus. Now I'm just going to pour. I don't care if all the lye ends up in, but I want most of it in. Maybe tease a little off here. Any lye left over is just going to stay on there. We're going to do that. We're going to spread it up. Okay, so you notice a color change right off the bat, right? Went to green and now it's gone to yellow, so we're rather caustic. We have a lot more lye than we have vinegar, but we saw a change. If you do this at home, you'll feel that it's hot. This is an exothermic reaction, gives off heat. So we got our color change. So we're going to put our mass back on there. Actually, while it settles, I'm going to record that color change in our observations. Let's go back to our lab book and said, when mixed, turned green and then yellow. Okay. So now, if we take a look at our balance, we are right where we were before, just a hair below. So our ending mass is 224.2 grams. So we're going to record that in our lab notebook. So mass 224.2 grams. Okay. So now we're going to ask ourselves, are there any other observations we need to make? It heated up. One of the reasons we put the watch glass on top is, if you'll notice, you'll see it's kind of cloudy here now. Because it heated up, so the water vaporized and it hits the cold glass around the outside and condenses back. Same with the cover slip on top, so that tries to keep some of that vaporization of the water from escaping. So might be good to record that just in case. So let's go back to our lab and let's say, we'll say water condensed on inside of beaker. So that's another observation. Beyond that, I don't think we got any observations. So let's go ahead and go on to our next part of our lab. So in my class, I agreed your labs. Oops. And so on the next line, we're going to put the most important part of the lab on here. Conclusion, where we analyze our data and address our hypothesis, amongst other things. This is worth 50% of your lab. If you forget to do your conclusion, it's half off. We'll do a few conclusions together, but after that, I'll often rely on you to do your own conclusions, so don't forget it. So in a conclusion, the first thing we generally do is restate what happened, okay? And you don't have to restate word by word, point by point, we just kind of condense it. So when we mixed the vinegar and lye, the solution changed color, showing a chemical reaction occurred. I'm going to scroll up a little bit. Okay, So that's kind of what we saw. Let's see. The mass did not change. Let's put that. Let's say that's the mass before the reaction was the same as cap locks. I'm yelling at you. As the mass after the reaction. So now we address our hypothesis. Our hypothesis was, in a vinegar and lye reaction, mass will be conserved. So if the mass before the reaction was the same as the mass after reaction, so mass was conserved. We didn't lose any mass, we didn't gain any mass. Our, oops, I can't type, hypothesis was correct. Okay. So in our conclusion, we kind of restate what happened. We analyze any of our data. Our analyzation was 224.2 equals 224.2. So the mass before the reaction was the same as the mass after the reaction, so it was conserved. And then we say whether our hypothesis was correct or not. Only other things we could add in here is any real-life applications, or if our hypothesis was incorrect, we didn't find that our hypothesis was correct, we could address possible reasons for that and maybe address how we changed the experiment to see if we could change the results. Okay, so that's the end of this experiment. If you wrote down this entire experiment in your lab notebook, you get it to me. It's an easy 100% right there, so good for you. Okay, so that ends the law of mass conservation. Hopefully that helps you understand a little better. If you have any questions or don't understand what happened, feel free to drop me an email at mrc@mrcscience.com. Thank you.